Today we're going to be learning about exponential graphs. Our objective is that we will be able to describe the features of exponential graphs. Alright, so first we're going to use Desmos to sketch a graph of f of x equals 2 to the x power. So there we can kind of see our curve. So here's our y-axis, our x-axis, and our graph curves slowly and then faster. So where is the y-intercept? It is at 0, 1. Does it have an x-intercept? So let's look at our x-axis, getting close, trying to figure out where it crosses. We keep zooming in. It's getting really close to that x-axis. We're down to 0.01. But look, there's still space there. So it does not appear to have an x-intercept. So as we keep zooming in on here, all right, there's more space, but we're down to like 0.00005. Let me go over. It gets closer, but it doesn't touches. And this is because there's what's called a horizontal asymptote there. It's an invisible line that the graph never touches. So for our graph of f of x equals 2 to the x power, it's getting closer and closer to y equals 0, but doesn't actually touch it. But what if we change our equation to f of x equals 2 to the x plus 3? And when you put your plus 3, since it's the same size as the 2, you know it's not in the exponent. So now what happened to it? Now it looks like it gets closer and closer to 3. So adding 3 to the end moved our our horizontal asymptote up to y equals 3. So let's look at the end behavior of this, of y equals to the 2x, or 2 to the x power, sorry. So let's look at what happens. As x goes to positive infinity, okay, it's our arrow on the right, our line is getting more and more positive. So it's also going towards positive infinity. As we go left, as x goes to negative infinity, f of x is getting closer and closer to 0. So let's look what happens if we put the plus 3 back on the end. So as x goes to positive infinity, f of x is also getting more and more positive. But as x goes more and more negative, negative infinity, our y values are getting closer and closer to 3. So again, adding that 3 on the end changed where our y values were going as x approached negative infinity. Now let's see what happens if we have a fraction being raised to an exponent. So instead of 2, we have 1/2. So the biggest difference you'll notice is the first one was going up. It was a growth. Now we have an exponential decay. So again, we do have a horizontal asymptote, so if we look to the right, it's getting closer and closer to 0, but doesn't touch it. So it's still, this one has a horizontal asymptote at y equals 0. But what happens if we put a -4 at the end of our equation? Oh, look, our asymptote moved down, and now we're getting closer and closer to -4. All right, let's look at our end behavior. As x goes to positive infinity, so that's on the right, now that one has the f of x that's getting closer and closer to the asymptote, so 0. And as we go left forever on the x's towards negative infinity, the f of x or our y values are going more and more positive, so positive infinity. What if we put the -4 back on the end? As x gets more and more positive, going to the right, our values are getting closer to -4. And as our x values go negative, meaning on the left, our y values, our f of x, is going more and more positive. All right, so let's look at some equations. H of x equals 1.08 to the x power plus 2. So for growth or decay factor, we're looking at the number inside the parentheses. So in this case, it's 1.08. For our next one, it would be 0.75. This one, 3.2. And this one, 1/4. These growth or decay factors can actually tell us whether our function is going to be increasing or decreasing. If our factor is a growth factor, meaning it's more than 1, we know it'll be increasing. If it's a number less than 1, we know our function will be decreasing. 3.2 is more than 1, so we know it'll be increasing. 1/4 is less than 1, so we know this one will be decreasing. Okay. The horizontal asymptote those 3 pieces over there. Our horizontal asymptote is going to come from the value on the end. And if there's not a value there, then you know it's 0. So in this case, it would be y equals 2. This one, it would be y equals 4, y equals -1, and y equals -3. For the y-intercept and the end behavior, I recommend graphing it on Desmos and looking at that. If you need the graph to help you figure out whether it's increasing and decreasing or where the asymptote might be, it's perfectly fine with me if you put it in Desmos as well. It's not a big deal. Use your graph to help you figure things out. So 1.08 plus 2. There we go. So our y-intercept is at 0, 3. And our end behavior. As x goes to positive infinity, f of x is also going positive. And as x goes to negative infinity, that's the side getting closer to our asymptote, so it's going towards 2. All right, so in our second one, our y-intercept is at 0, 5. As x goes positive on the right, that's the side getting closer to our asymptote, so it's going towards 4. And then as x goes negative, our left-hand side is going up towards positive infinity. All right, so this time our y-intercept is at 0, 0. As x goes to positive infinity, f of x is also going to positive infinity. And then as x goes to negative infinity, that side's going towards our asymptote at -1. Our final one, 1/4 minus 3. So our y-intercept is at 0, -2. As x goes positive, our right-hand side is getting closer to our asymptote at -3. And as x goes to negative infinity, our left-hand side, our arrow is pointing up towards positive infinity. Something to point out about the y-intercepts, the y-intercept is always one more than the asymptote. And our end behavior, if it's increasing, the positive side goes to positive infinity. If it's decreasing, the negative side goes to positive infinity. That's all for today. I'll see you in class.